Good morning. My name is Heinz Arnold. I'm senior editor of Markt&Technik, and I have the pleasure to talk today to Professor Pöchmüller, who is responsible for a company called Intelligent Memory. And he works in the memory technology for many years now. He was with Neumonda, and he invented the so-called buried word line technology, which which after Neumonda went bust, became suddenly known in the industry all over, and is used, I think, by every company today. He is now developing a new test methodology, and this methodology promises to reduce the cost for testing in order of magnitudes. And we will learn today what are the secrets behind it. Mr. Pöchmüller, would you mind just to introduce yourself very briefly, what you did before, what the company Intelligent Memory is all about, and how it fits in the Neumonda group?
Okay. Thank you for giving me the opportunity of speaking here. So my name is Peter. Peter is enough.
Okay.
I worked many years in the US. Nobody calls me Mr. Pöchmüller. So Peter, I'm CEO of Neumonda Group, and we have 3 business units. One is Memphis distribution, one is Intelligent Memory, doing own product brand, and one is Neumonda Technology, doing IP stuff and new technologies like this tester board. As you mentioned before, I worked many years in the DRAM industry with Siemens, Infineon, Neumonda, and you gave me too much honor. I'm a chip designer. I did not invent the buried word line technology. That was done by Mr. Dr. Küsters and his technology team, a team effort of Neumonda at that time. I'm a chip designer, so I know what chips are realized in this technology and what problems we have in testing them. And after the insolvency of Neumonda, I became first a consultant, later CTO of Intelligent Memory, and I saw all the problems this company has by making new designs, new products, taking wafers from a wafer producer, and then provide customized solution for industrial partners, for example, for German industry. Everywhere where you have an electronic product today, there is memory in it, flash or DRAM, medical equipment, avionics, satellites, scanning systems, and they have special requirements. And those special requirements are very difficult to handle if you cannot test on your own. And this was the motivation.
Okay, you said you are now in a unique position for testing devices. Could you tell us a little bit about what is so unique and what could you offer which others couldn't, and which markets are you aiming at with these capabilities?
The uniqueness of Neumonda Group is that we combine those 3 business units, and I think you will not find a similar company again. Memphis has customers, 2,000 customers in total. So the customers sometimes take small volumes, also have sometimes no perfect board designs. A customer coming, oh, my memory cell, my DRAM has single cell errors. Then you tell them, adjust a little bit driver strength, oh, it disappears. So there are imperfections in their designs, robustness issues, and this over a huge bunch of customers, and those customers with special requirements. I need a product for a higher temperature environment. I need a product which is more robust in a welding environment or in space environment. So we understand the requirements of a multitude of customers better than the big producers like Samsung or Hynix, who usually do not support such small customers.
And this device here is replacing big test machines, or?
Today, if I do a specialty product for industry, I use a 3-ton burn-in tester to age it. I use a 3-ton tester for doing array memory cell testing. And I use another 3-ton tester for speed testing. So 10 tons of equipment, which I will replace by this 10 kilograms of equipment.
Mm-hmm. So you want to enter the business of test equipment?
It's not my prime motivation. My prime motivation is to become independent, that I can efficiently provide solutions to smaller volume customers. Or in November, a customer came to me and said, "Oh, Peter, we've heard you have an equipment here. Can you provide me 70 years longevity support, 70 years of support? There are some equipments, they're designed for a long time. Think of a Boeing jumbo jet, used for many years. Those customers put chips into nitrogen environments, store it for many years, then they come out and they cannot test them anymore because the test systems are gone. This is one example of the power of the system. So I want to use it primarily for ourselves. And then if it's mature and working, you can think about giving it to other companies as well.
So this is the prototype?
This is the first prototype which came out in November last year.
Mm-hmm. And it's working?
It's working with the imperfections of a prototype because in the first solution we still use a lot of IP, for example, of the FPGA provider. We have one row is functioning, the other one, the delay is too long, so we have to redesign it. That's typical imperfections of a prototype. But very quickly we will have a version which I can use internally then, starting from summer.
When do you think you could offer the first systems to the open market?
As I said, open market is for me second priority. The open market is for me interesting because I want to collect even more feedback from more than our own 2,000 customers, so I can further improve the test patterns and the system. So my target is maybe to have mid next year something we can give to other companies as well, which we are not only using in-house.
Okay. And what are the goals for this year for your company?
So this prototype is now working. Roughly, we will make the improvements we learned from this first version. That will take maybe until May or June. Then we have a more mature version. We also have to provide the infrastructure for this, automatic loading, that those boards are automatically loaded, automatically unloaded, and the climate chambers, because we have to test from -40 to +125 degrees. This will be available by July or August. Then we start in-house production, and then hopefully mid next year we have also something we could share with others.
Okay, so you're looking for working together with the big suppliers of memory ICs as well as the users of memory ICs?
Correct, both, because there are companies coming with special requirements, and the killer is usually testing, because industrial customers don't have the volume which cause the interest of the big wafer suppliers. But this board, because we are looking from customer view, customer application, also for the wafer producers, we think this board will have a lot of advantages, because you can have much earlier a mature test program by using application-based patterns, and I also think the yield will go up. So you also have benefits as a wafer supplier.
Okay, so you said your first goal is not to reduce costs, but could you give just a hint of what is possible in terms of dollars?
And it depends how you determine or define cost. The cost per piece, testing one component, if you have a production tester, 10 tons, $10 million invest. If you produce 100 million parts, this is an efficient solution. So my target is to reach similar costs, but I can support much longer time test. If necessary, I can test for a week, because we have special effects in memory technology that happen within hours or days. And this you cannot catch by today's testing, which has to be done within 20 minutes. And I can support small customer coming, Peter, I have here an industrial product, still 20 more years in the market. This semiconductor does not exist anymore. Can you do it for me? I can do it. I can design a special tester board for them. It's relatively cheap, and I can support such small volume individual customers.
Okay, and we are talking about DRAMs now, or is this possible to apply to other memory technologies as well?
Today, we are talking DRAM. This is my first priority, DRAM components. Then I will extend it to LP, DDR, and next step flash, because we also prepare a big flash portfolio. When you have the infrastructure in place and redesigning the board and the electronics is not so expensive, you can fundamentally test whatever you want. And the real crown jewel in the future would be, there we are cooperating with 2 universities in Germany. You want to analyze the patterns, the application of the customer. What is he doing with his controller and his application? Then you program this into an FPGA environment and you run exactly the pattern the customer is running in his application. This way you will get the best quality and the least overhead. Why implement in your test a technology pattern which finds some failing cells in exotic tests which never happen in a customer application? This is redundant, this is overhead. So this will be the final step that I can even do for a specific application, an own tester. You reconfigure it, you reprogram it, and then it's doing what the customer application is doing.
And the prospective customers, do they see the advantages, or is it still a lot of work to convince them?
Industrial customers are conservative. Those customers which are coming today to me, they have no choice. The product is gone, they need it, nobody else can offer it. Those customers are desperate and accept everything. This had been the first customer of this new methodology. We delivered to them, and so far the quality very good, superior. Not a single part came back as defect.
Okay.
So, but industrial customer are conservative. You need to do it step by step to get the concerns down. Yeah, this is a new approach. Here, everything is radically new. The parts are not moving to the tester anymore. You take the tester, and the tester moves through the factory.
Okay.
I turn everything upside down.
Okay, so as long as there are enough customers who have no choice and come to you, seems to be a very good business model. I wish you all the luck of the world, and thank you very much for answering my questions.
Thank you.